Hello, and welcome to this lesson on the reactions of the first three alkali metals with oxygen, chlorine, and water. In today's lesson, we will describe the reactions of lithium, sodium, and potassium with oxygen. We will also discuss how lithium, sodium, and potassium react with chlorine. Finally, we will examine the reactions of these alkali metals with water. So far, we have explored the reactivities and properties of the alkali metals. You are already familiar with these elements' high reactivity and the trends in their physical and chemical properties as you move down Group 1 of the periodic table. Building on this foundation, today's lesson will deepen our understanding by examining the specific reactions of lithium, sodium, and potassium with oxygen, chlorine, and water. These reactions highlight the unique behavior of alkali metals in different environments. Let's dive into the fascinating world of alkali metals and their reactions with oxygen, chlorine, and water. We'll explore the specifics for lithium, sodium, and potassium. First, let's look at how alkali metals react with oxygen. When alkali metals react with oxygen, they form metal oxides. For example, when lithium reacts with oxygen, the chemical equation is 4Li plus O2 becomes 2Li2O. Here, lithium oxide is formed, which is a white solid powder. This reaction is exothermic, meaning it releases heat. Each metal has a characteristic flame color when it burns. Lithium is a crimson red, sodium is a yellow-orange, and potassium is lilac. These flame colors are important to remember as they help in identifying the metals. You need to learn these colors for your GCSE exam. Next, we focus on the reactions with chlorine. Alkali metals react vigorously with chlorine to form metal chlorides. For potassium, the reaction is represented by the chemical formula 2K plus Cl2 becomes 2KCl. This reaction is highly exothermic and may produce bright flames or sparks. The product is potassium chloride, a white solid metal chloride powder. This pattern of behavior follows for lithium and sodium as well, forming lithium chloride and sodium chloride respectively. Lastly, let's consider the reactions with water. Alkali metals react vigorously with water to form metal hydroxides and hydrogen gas. For sodium, the reaction can be written as 2Na plus 2H2O becomes 2NaOH plus H2. This highly exothermic reaction leads to the formation of sodium hydroxide, which dissolves in water to create a colorless alkaline solution. Here's what happens when each of these metals reacts with water. Lithium fizzes, floats, and moves on the water surface. Sodium fizzes, floats, moves rapidly, and melts into a ball. Potassium fizzes, floats, moves, melts, and burns with a lilac flame. It's crucial to note that these reactions become more vigorous as you go down the group. For instance, cesium, which is lower in the group than lithium, sodium, and potassium, reacts explosively with water. Understanding these reactions helps us appreciate the increasing reactivity as we move down Group 1 in the periodic table. By observing factors such as flame colors, the nature of the reactants, and the types of products formed, we develop a deeper understanding of the properties and behaviors of alkali metals. Well done, that's all for today. Let's quickly recap what we covered. Firstly, we looked at the reactions of lithium, sodium, and potassium with oxygen. When alkali metals react with oxygen, they form metal oxides. Each metal has a characteristic flame color when it burns. Lithium burns with a crimson red flame, sodium with a yellow-orange flame, and potassium with a lilac flame. We also learned that the alkali metals react vigorously with chlorine to form metal chlorides. Finally, we learned that the alkali metals react vigorously with water to form metal hydroxides and hydrogen gas. These reactions have different appearances for each alkali metal. Lithium fizzes, floats, and moves on the water surface. Sodium fizzes, floats, moves rapidly, and melts into a ball. Potassium fizzes, floats, moves, melts, and burns with a lilac flame. Throughout this lesson, we noted that the reactivity of alkali metals increases as we move down the group. Understanding these reactions provides a foundation for predicting the behaviour of other Group 1 elements and their interactions with different substances. This lesson has enhanced our grasp of the properties and reactivities of the alkali metals, setting the stage for further exploration of the periodic table.